All right, let's talk about integrals in calculus. Definite versus indefinite integrals. What do we mean by this? Well, let's go ahead and talk about indefinite integrals first, because this is the easiest to wrap your head around, and it's probably what you learn first in a calculus course. The indefinite integral is just another way to say the antiderivative All right, so what do we mean now? What do we mean by antiderivative? Well, if x squared has a derivative, if we take the prime of x squared and we get that that prime is, bring the 2 down, 2x, using the power rule, then the antiderivative of 2x is just x squared. So we can write this using integrals. So let's go ahead and do that. Here's the symbol that means integrate. All right, so we're going to have the integral symbol and then some function, and then dx. And this is, all this is saying is, this right here says, what function, when I take its derivative, gives me this, gives me f of x. So, something, don't know what, prime equals f of x. That is what this is saying. So let's do an example of this. So let's do an indefinite integral of the exact same thing over here. An indefinite integral of 2x dx. So this is just saying what function, when I take its derivative, gives me 2x. So the indefinite integral of 2x is, well, x squared, right? All this is saying is, what's the antiderivative? All right, so now let's talk about definite integrals. This is a little bit different, this is a little bit trickier, but it's really, really cool. Definite integrals, and these are important in the fundamental theorem of calculus, which just tells us that taking area of anything is really, really easy. So what if we have a function, and like a really nasty function? Okay, if I have a box, and this is my height, and this is my base, then I know that I can find the area of this box, a equals b times h. This is elementary school math. This is not hard because it's a square. But what if we have this? What if we have this kind of function? We have not a box, but something that looks like that. And we want to know from point A to point B, let's draw our little lines up through here, how much space is in this right here? Well, man, we can't just say base times height. Yeah, I mean, this is really, really ugly. So what do we need to do? Well, we need to take a definite integral. And here's how this looks. All right, so ourselves some room. All right, same symbol, but A to B. These are starting and stopping points is a good way to think about it. This is the interval over which we're evaluating this function. Something over a to b, and we're going to have a function inside of this, just like we did over on our indefinite integral. But while indefinite integrals take functions and spit out other functions, definite integrals take, well, simple definite integrals take functions and spit out values, and what they're spitting out is functions for area, not functions for area, but values for area, or if you get more complicated, functions that allow you to evaluate area over different endpoints. So, the integral over, the definite integral over a to b of some function, let's just say cosine sine x, or better yet, x squared. Let's make this really easy once again. Of x squared, what's the integral of this? What's the definite integral of this? Well, let's just draw x squared. It's a really simple parabola. It's the parent function, right? So here's x squared over a to b. A to b can be any points we want. A could be, this could be saying the definite integral of x squared over 0, 7. So let's do that. Over 0, 7, so here's 0, and we'll say here's 7, right? So it's saying, the function goes up here, so let's do this. How much area is in here? Well, if you take the definite integral, you're going to find out how much area is in there. You're done. That's all you have to do. So, a quick recap. Definite integrals or indefinite integrals, take functions and spit out another function that when you take the derivative of that function, you get the function inside of the indefinite integral. A much simpler way to say that is the indefinite integral is the antiderivative of the function you're evaluating. A definite integral does not spit out functions, it spits out values of area. So I don't know what the, over b to a, we'll just say because this is abstract, let's say hypothetically that the definite integral of x squared over a to b was 4. Then we know that that's how much area is underneath that part of the graph to the x-axis. So that's all a definite integral is. It takes a function and it spits out area. So there you go. Those are those two.